So in this video we're going to look at the Zener diode. I have one right here. Zener diodes come in a range of voltages. You may notice that it looks like a regular diode schematic symbol, but a couple other lines which kind of look like a Z, and that it is reverse bias. So we have the positive side of the power supply that we need to limit the current, making it to the Zener diode and to the load. And whatever current doesn't get used up by the load, a voltage builds up here, and at a certain voltage, depending on the Zener voltage of the particular Zener diode you use, current will start flowing through the Zener diode. And what that does is, at this point right here, it takes the power source voltage and reduces it to the Zener voltage of the Zener diode. And Zener diodes, especially at low value, aren't terribly accurate. You have to be careful of the current you put through them, and they're kind of a tricky component to use, so you don't see them a lot, but we're going to look at them a bit in this video. So now, to begin with, we're going to look at this particular Zener diode wired up just like this. The voltage out here doesn't go into anything yet, just this spot here, but you can see we have a 220 ohm resistor there and the Zener diode there. This is a 4.7 volt Zener diode. The part number, I took it out of this bag. It's from the Joe Knows Electronics kit, 1N5230. And that part number is not written on the diode though. We will look at that coming up. But in any case, we have the meter here set to measure 20 volts or less. Made sure the probe is in the voltage spot, and we will take a voltage reading where the Zener diode and the resistor come together. And there you can see it's slightly less than 4.7 volts. If we pass a little bit more current by using a lower value resistor, then the voltage would probably go up a little bit, but it's in the range of 4.7 volts. Now I'm going to take a 1000 microfarad capacitor here. It is polarized, and so we need to put the negative side to the negative rail, and the positive side we'll put to where we have the resistor and the Zener diode connected. So right there, and there you can see it's connected there. If we take the voltage measurement, again, it's a little less than 4.7 volts. So that's what we charged the capacitor to. And now we're going to swap out the capacitor for a resistive load and a semiconductive load. And so this is a 1000 ohm resistor, 1 kilo ohm resistor right there, and we'll put the LED here. So it should be a little less bright than it would be with 5 volts, the 5 volt power supply, because now we have 4.7 volts, which is still really close to 5 volts, so not too noticeable. But up there, now you can see there's a bit more of a voltage drop. So the current that's going, this is a 1 kilo ohm resistor, that's a 220 ohm resistor, and we also have the LED blocking some voltage, so not a lot of current, but still it's enough to drag the voltage down a bit. So the Zener diode isn't perfect. As I said before, there's better options, but still it's an important component to learn and an interesting component. So now moving along, the Zener diodes that we had, here's half the components in this kit. Here's the other half of the components in the kit. It's the Joe Knows Electronics semiconductor kit. Kit I use in a lot of videos. I take components out of here. But in any case, we have these Zener diodes. I plucked out these 4 lowest value ones because we're only using a 5 volt power supply. We need a higher voltage power supply than a Zener diode we're going to use. And as we saw, as long as we keep current low, we were close to 4.7 volts with the 1N5230. Now let's look at the lowest value here and see how it does. It should not do near as well. So it's the 5221. It's rated for 2.4 volts. First thing we'll do is measure it with my automatic component tester. So now I have inserted into the tester a Zener diode, cathode to number 1 slot, and then the anode to number 3 slot. We will hit the tester. So this is the 1N5221. It's a 2.4 volt Zener diode, and as you can see here, it shows a diode going one way and then a diode going the other way. That's because the Zener diode, while it's forward biased, it does still conduct current at about 0.7 volts, in that range. But while it's reverse biased, it also conducts some current, and this tester looks like it's pretty accurate right now. It says 2.3 volts, where this component is rated for 2.4 volts. And we can take this out. I think it will hold steady there. So now the part number isn't on this component, but let's see if I can find a good way to take a look at this. But you'll see the number on here. There we go. So you see 2, V, and then 4. So V is in place of the decimal point. So 2.4. So you know this is a 2.4 volt Zener diode. And now I swapped it out with a 3.3 volt diode, the anode to pin 1, or to slot 1, and then the cathode to one of the slot 3s, and we will test it out. So this is the 1N5226, and according to the Joe Knows Electronics datasheet, it's a 3.3 volt Zener diode, and so it looks like it's down to 3 volts, so not as close to its rated value as the other Zener diode. And the amount of current that the meter passes through, if we could get the current right, it probably would get to 3.3 volts, but these lower voltage Zener diodes are more finicky. But in any case, let's see if we can read the voltage there. So yep, see 3, and then V, and then 3 for 3.3 volts. And now I have the 3.3 volt, the 1N5226B, according to the Joe Knows Electronics kit diode. But as we saw, that part number is not on there. And there we can see it's actually holding 3.3 volts pretty nicely there. So for this amount of current that's going through the Zener diode, and then the rest of the current's going through the resistor and the LED, it actually holds that voltage pretty well. So we would want that current going through that Zener diode under different circumstances if we wanted it to hold that voltage. So these lower voltage ones, as I said before, are not as good at holding the voltage as the better ones, but it's doing pretty good in this demonstration. So now the capacitor should really rapidly charge to about 3.3 volts, and there we have about 3.4 volts. So now the capacitor, it's going to go up a bit, because once it charges to, in this case, 3.4 volts, it's not passing any current anymore, just a little bit of leakage, but that's very small. Now there's more current, since there's really none going through the load anymore, more current going through the Zener diode, and so the voltage went up a bit. So that's the way semiconductors work. Generally, the more current you put through them, the more voltage they start blocking. But they have a range of voltages based on their rated voltage. So now we're going to take an LED, forward biased LED, because it blocks way too much voltage reverse bias. But we can take it and put it forward bias, and now we're going to have, since we have a 220 ohm resistor there, about 2 volts where the LED and the resistor come together. So let's pull back on that, and so you don't have to use a Zener diode to get a set voltage in the same way. You can use a forward bias semiconductor. There we go, spot on 2 volts. That's where the resistor there and the LED connect. And so if we just have a low value resistor like this is actually a 1000 microfarad, but still that's relatively low, and I don't know what I did wrong there, but the LED turned off. So now, apparently, I burnt out the other LED. So this must have had, it's a 1 1000 microfarad capacitor. Must have had some charge on it, so I discharged it. I stuck it to probably the negative to negative rail, doesn't matter, negative to negative, positive to positive, as long as it's a short circuit. To discharge it, it's a low value capacitor, even though apparently it can fry a LED with its stored charge. So we'll put it there, and we should have saw that the LED would come on. So now we have this fixed. Problem was we fried this board, at least that was one of the problems. We also fried an LED. This was only outputting 2.5 volts and probably couldn't even output much current after that. So I don't know if this happened because I damaged it earlier. I short-circuited it a couple times in an earlier video. But in any case, we are back to this working. So I have the capacitor there. I will pluck it out now. And what I wanted to do is I should have discharged the capacitor first. There might have been a charge on it. That might have had something to do with it. But in any case, we will take the capacitor there. It's a 1000 microfarad capacitor. Now I'm going to put it where the resistor and the LED come together, and you should see the LED get dim for a little bit. That was while the capacitor was charging. So it took all the current from the LED until the LED had until the capacitor, I should say, charged to about 1.5 volts, so that current could start charging through flowing through the LED to ground. But in any case, now we should see that with the other multimeter probe there, that the voltage across the capacitor should be held down to the forward voltage of the LED, which is somewhere around 2 volts with this much current going through it. So it's a little lower for whatever reason. We'll yank this out, check out the voltage right there, and we can see it's 1.85. So it's a different power supply. Maybe that makes a difference. But in any case, you don't have to use Zener diodes to get basically a Zener voltage. You can use regular diodes, LEDs, and the amount of current still, as I said, will make some variation. And so generally semiconductor voltages go up a bit when you increase the current and down a bit when you decrease the current. Apparently about 7 volt Zener diodes they hold theirs pretty good. I think it's 6 or 7, in that range or something. But as you drift farther from that, I guess they don't hold, especially going down, the voltage as well. But in any case, that's stuff to research, test out, whatever you want to do. I'm going to end this video here. There's a lot of testing you can do. It's an interesting component. You read about it a lot, but you don't see it in many circuits, the Zener diode.